So moving further from probability distribution, we want to move to expected value. So notice what we have here, expected value, that's e of x, it is a function, is the sum, remember the symbol I showed you in the previous video. So this is x times p of x. So you've got your number of outcomes times the probability of that outcome. So technically what this means, if I've got x times p of x, it means I'll take the first x amount times its probability plus the second x amount times its probability plus the third x amount times its probability, and it goes on and on. So really all this is a type of average. Okay, it's not like averaging grades, but it is a different type of average. So let's work the problem. The sum of all outcomes times their probabilities of occurring. Okay, that's the definition again. So I've got a $20 bill, two $10 bills, three $5 bills, and four $1 bills, and they're placed in a bag. If a bill is chosen at random, in other words, they're mixed up, you stick your hand in the bag and you just grab one. What is the expected value of the amount chosen? So we're looking for expected value, okay? So that's going to be a number. It's going to be a value for the amount chosen. So what that does is kind of helps you figure out how you make your little table like I did with the M&Ms. So I know there's a dollar bill, there's a $5 bill, there's $10 bill, and there's a $20 bill, okay? So we know that's what we have. So our X, which is the number of each outcome, there are a $20 bill, there's only one of those. There's two 10s, there's three 5s, and there's four 1s. So we start this out just like we did the probability distribution. So now I've got to find the probability. So that means there are, let's add up these bills. I've got 4, 7, 8, 9, 10. So I have 10 total bills in the bag. Alrighty, so you always want to add that up. So that means I'll have 4 tenths, 3 tenths, 2 tenths, and 1 tenth. So it's very convenient to then, because people just generally grab the calculator to do this, and that's totally fine. It's a little bit easier, I think, to enter in the decimal than it is maybe the fraction sometimes, but the fractions do work. So we're going to still use this value and this value. This is our x, this is our p of x, and so we're going to go ahead, I'm trying to keep this in my camera, we're going to try to go ahead now and calculate the expected value. So this is the, I'm going to write this down, expected value of the amount chosen. Alrighty, so what we'll have, hold on, I think I'm incorrect here. So this is what you're going to look at for your x. Sorry, I told you a whopper. Because what you need the value amount, because that's what you're looking for. You're looking for the amount or the dollar worth that you chose. So I have $1. I'm going to put the dollar sign so you know what we have. I have its probability. Plus, I have a $5 bill times its probability. Plus, the $10 bill times its probability. Plus, the $20 bill times its probability. So when you run the calculator on that, so this is your expected value of the amount chosen. In other words, what do I expect to draw out of there? Okay, and remember this is sort of an average. So what I got was $5.90. I did this earlier. Let me go ahead and just crunch it again. I don't remember if I rounded or if that's exactly what it was. So I'm just entering this into my calculator. Yeah, it was exactly $5.90. So what, it said 5.9, so this is money. So this is $5.90. Now remember, this is an average. It's kind of like somebody asking, what is the average number of children born to a household? And they always give you this wild number like 2.3 children. That is a statistical average. And so whenever you have that, you always want to go 1 to 2 decimal places beyond what you're looking at. So if you'll notice our money values, they're all to the unit, okay? So we want to go 1 decimal to 2 decimal places larger to calculate our average. So what we want to think is, over the long run, this is what this means. Over the long run, we would expect, on the average, you have to throw all that in there. Over the long run, we expect, on the average, to draw $5.90 out of the bag. Now, I know you're not going to draw $5.90, but really what this means is you can probably expect to maybe just draw a $5 bill, maybe a $1 bill. It's closer into those numbers. So that's what expected value is.